Hey guys, welcome. Thanks for coming back. We're going to do a little more with our solubility curves and some data collection with some labs. So thanks for popping in. Grab your packet. Don't forget homework that you might have coming up as far as completing the lab that we start today. And if you haven't already, start reviewing for your Unit 3 tests. There's a review packet in Schoology now that should help a lot with that. Tests will be coming up very soon, as you guys can see. Let's continue on with where we are. Question of the day, guys. What form of sugar dissolves the fastest? If I put both of these in water, stir them up, keeping all their factors like temperature and stirring and other things the same, which will dissolve fastest? Right, powdered sugar, but why? What's going on? Well, if you add water to our sugar, or sugar to our water, the water is going to have to try to get into the center of that sugar to dissolve the sugar in the middle. It's not going to be able to actually access this until the surface has already been dissolved, whereas powdered sugar has plenty of surfaces where water can get into because it's already in a small form. And dissolving just really means that we're breaking it up into tiny little molecule-sized pieces. So there's less surface area on these sugar cubes than there is on all of these pieces of powder added up. There's just more surfaces for water to interact with the sugar. Let's talk more about solubility, and now we're going to look a little bit more at temperature because that is also another big factor that affects our solubility. So when I see a graph or table, I should say like this, I want to keep in mind that the column here on the left is what I would normally find on the x-axis of a graph, whereas the information on the right is on the y. That's just kind of an alphabetical thing, right? X and y. So graphing, we put our x and our y. So if I'm looking at temperature, temperature will be on the x, whereas grams that can dissolve will be on the y. So an increase in temperature could mean an increase or decrease of the amount of material that can dissolve, or solubility. Let's take a look at putting this into practice. So in your packet, you'll notice that you'll have this page. I think it was labeled homework, but of course we're going to do it now together. So I'm going to look at my column on the left. That's my x-axis, that's temperature, compared to my y-axis, which is the amount or grams. Okay, so I've done the first one because at 0 degrees Celsius, 30 grams of material can dissolve. This is ammonium chloride. All right, let's try the next one. Let's find 20 degrees. At 20 degrees, I can put 37 grams of ammonium chloride into the solution, and it will dissolve. That's the maximum amount. I couldn't put any more in. I'm creating a saturated solution. Go ahead and complete the rest of your graph by finding the different temperatures. And make sure your x intersects the line. Now we can continue until you've completed the graph. Okay, go ahead and connect your x's with a nice straight line. And you see something about the solubility of ammonium chloride. So what can we do with this? We can ask questions like, what's the maximum amount of sodium chloride that can dissolve at 70 degrees? Now 70 degrees is not on our table. Notice I go from 60 to 80. Rather than estimating from these numbers, I'm going to look at the graph itself. Find 70 degrees. Find where this line intersects the graph. And this is an inference I can make about what would happen if I heated the water to 70 degrees. As you can see, it wasn't actually done. It's a shade over 60. So 61 grams dissolve at 70 degrees. What's the relationship? All right, let's think what happens as we change the x, or we change the value we call the independent variable. The one thing I'm controlling is temperature. So if I increase the temperature, what happens to the amount of material that dissolves? Let's look at the shape of the line. The line tends to rise, goes up. So that means as I increase the value of temperature, I'm also increasing the value of solubility. So to put it in a sentence, the relationship between water temperature and the solubility of this material would be stated as the following. As the temperature increases, the solubility of the material also increases. Relationships are always comparing the two values. We all usually start with our x and compare it to our y. All right, let's look on the next page. What happens to the water temperature when we go from 30 to 90 degrees? How does that affect potassium bromide? Well, first we have to find potassium bromide. Labeled for us right about there. As we go from 30 to 90 degrees, we're going to notice an increase in the amount of potassium bromide. Looks like we're starting at 70. And we're increasing that up to 90 degrees, which intersects the line there. So what's the increase in grams from 70 up to 100? Well, that's an increase of 30 grams. 30 more grams of material can be dissolved as the temperature increases from there to there. The increase in solubility can be measured here. All right, we're going to take a look at doing a lab. First, look at your question. Is it possible to change the solubility of a solute by changing the temperature? According to our notes, we assume it is possible. Don't forget, solubility measures the solute, the material that dissolves, into a solvent at a given temperature. And we know it's a physical property. Let's look at our variables. Independent variable is the thing that we are going to change. We are going to be changing the temperature. Of the water. Dependent variable. Think about what that means. What will depend on the change in temperature? So depending on the temperature, the amount of material that can dissolve will change. Let's make a hypothesis. If we change the temperature, what will happen to the amount of dissolved material? Okay, so if the temperature, let's start with increase. You may have seen this form of hypothesis before, starting with if and including the word then. So we talk about what would happen if we manipulated something like temperature. If the temperature increases, what would happen to the amount of sugar that can dissolve? So you would finish that with your own hypothesis. What do you think would happen based on your knowledge? Would the amount of sugar increase or decrease? Go ahead and choose your answer. To do a lab like this, we would need water, of course, thermometer, beakers, sugar as our solute, a way to keep track of time, and a way to measure the mass. We'll prepare 4 independent beakers of 100 ml each with different temperature ranges, somewhere between 0 and 100. We'll measure the mass of our sugar, which could be represented by a lollipop, candy cane, or whatever you have handy that can be sugar. Maybe just it's a sugar cube. We'll gently stir whatever it is into the water for 5 minutes, shake off any extra water, and measure the remaining mass. I'm assuming after 5 minutes in water where you're gently stirring, some of that sugar will dissolve. The remaining mass can be used to find the difference, in other words, the total amount that dissolves. Before we do this, let's think about some factors that we must keep the same. We know that we're using different temperatures of water, so that's definitely going to change. But what needs to stay the same? Well, for sure the amount of water. Each beaker should have the same amount. In this case, we're going to identify that as 100 milliliters of water. If you're stirring it, the amount of stirring has to be the same. So how you stir the water needs to be exactly the same. Why? Because stirring is a factor that can change solubility. Think of some other factors that might be in play. Maybe the size of the containers. Let's make sure they're all the same. Any other factors that could influence this experiment? Well, sure, the condition of the sugar. So we're going to make sure that all of the materials, if they're lollipops or candy canes, are all in the same condition. We don't have some that are crushed up, because as we already talked about today, crushed sugar will dissolve quicker than a lump of sugar. So any variables other than temperature can go into this factoring in of our constants. All right. So after experimentation is done, we're going to be looking at temperatures ranging from 10 to 75 degrees. All the dum-dums are about 4 grams to start with. After 5 minutes, the dum-dum that was in the 10-degree water went from 4 grams to 3 grams. That's a change of 1 gram. That means 1 gram of the sugar dissolved at 10 degrees. Compare that to 75 degrees, where all that was left was about 1/10 of a gram. Most of the dum-dum dissolved. 3.9 grams had dissolved. So what's the most important data here that we have? Well, we have temperature. Remember, that's going to be the X value. And these are great for keeping track, but what we really want to measure is how much dissolved, which is this column here. So in your packet, this is the most important column compared to this column. These are the two columns that we're going to graph. How do we do this? Okay, set up your graph. You've got your title. We know that the x-axis is here. The y-axis is up and down. You're going to have to figure out how to set up your axis. Okay. For your graph, will you be skipping 5 boxes, 3 boxes, 10 boxes? Figure that out so that your scale works from 0 up to 4 being near the top. Same with temperature. We want to have consistent temperature scales from 0 to 100. Does that mean we skip every 5, 10, 15, 20, 25? How are you going to set up your graph? So sometimes that's the most difficult process of these graphs, is just figuring out how to set it up. Go ahead and do that. Now, take your graph data and let's graph the X value here compared to the Y value here. Wherever those values intersect, put an X or a dot, and then you can connect them with a line. Go ahead and do that, pause the video, and then we'll start back up again. How'd your line look? For most people, the line increases and looks something like this. As you heat up the water, more and more and more of the sugar is able to dissolve. You might have seen that in real life. If you compare iced tea to hot tea definitely can dissolve the sugar much more efficiently, quickly, and you can get more sugar into your hot tea than you can in iced tea. That's because the solubility rate of sugar is affected by temperature. All right, so you have some questions to complete. Of course, you'll be using your data and your graph that you made to do those. And then, of course, don't forget, we talked about your test coming up, and you've got your project coming up as well. So you can work on those things too. So hopefully that helped out. If you missed that part of class, there's your online lesson for solubility curves and making them. And hey, thanks for popping in. Thanks for trying science. We'll see you on the next one. Bye-bye.